All right. For forecasting, I think sometimes it's useful to actually see how you do the forecast. So I'm making this short video to show you how to do forecast using the same data in 6 different techniques, and then I'll show you how to calculate some forecast accuracy measures of those techniques so that you can see it demonstrated. I've adapted this data from Operations Management by William Stevenson, 14th edition, problem 26 in chapter 3, but I've changed it, so it's not exactly, but I did want to attribute where the data came from. So I'll start with the simplest first. We're going to do a simple moving average forecast with n equals 3. What that means is that in period 4, the forecast is going to be equal to the average of the previous 3 periods. So I'm just going to take the average of these previous 3 periods. So 79.333 is the average of 74, 80, and 84, and that's my forecast in period 5. Or sorry, that's for previous 3 periods, the forecast in period 4. So if I just drag that down now in Excel, it's not an Excel class, but it shows us how we can forecast all those numbers. So this gives me the forecasts for periods 4 through 14 using this data with simple moving average forecast. Now, I'm not going to calculate the accuracy measures yet, but I know I'm going to need the error for each one. So I'll do the error now. The error is equal to the actual demand minus the forecasted demand in each period. So that's what that looks like, right? All right, so that gives us the forecasts using simple moving average with n equals 3 for all of these numbers. Now, for in this tab, I'm going to do the simple moving average for n equals 4. So I can't start that until period 5 when I have 4 periods. Now what I'm going to do is pick these 4 numbers. So the forecast in period 5 is equal to 79.75, which is the average of those 4 numbers. Same thing, I can drag that down. So there are the forecasts, here are the errors. The actual demand minus the forecast demand. I'm not highlighting this last period because in this period there is no forecast demand. All right, weighted moving average. Now, you recall with a weighted moving average, what we're doing is we're giving different weights to different periods. What I'm doing here, we're going to say we're going to use 3 periods, and the most recent period we weighted 0.5. 0.3 for the period 2 periods away, and 3 periods away will be 0.2. So I'm going to go to this cell for the 4th period forecast. We're going to have it be equal to 0.5, which I'm going to make an absolute reference. It always goes back to that cell, times the most recent period, plus this cell, also absolute, times 2 periods ago, plus 0.2 times this period. And that gives me my forecast. And because of the way I did it, I should be able to just drag it down, and hopefully those numbers are all right. I could have just hard-coded these numbers in, but I like to make my spreadsheets general when I'm thinking about it in advance. The error is going to be the same, the actual demand minus the forecasted demand. That gives me my errors. All right, now we're to exponentially smooth. Now, the trouble, exponentially smooth models, you may recall, really only you require the forecast from the previous period or from that period plus the actual demand in that period. The tricky part is you need a forecast for each period. So what I'm going to do here is I'm going to say that the forecast in period 3 is equal to the demand in period 4 because that's my best, that's all the information I've got. And then from there, I'm going to actually apply my equation. Now I'm going to go ahead and calculate the errors beforehand because we use them in the exponentially smoothed formula. So what we're going to do here is take the actual demand minus the forecast demand. And I'll go ahead and drag those all the way down. even though there's nothing there yet. Now the forecast equation looks like this, if you recall. You take the forecast from the previous period plus the alpha value, which I didn't put down here, we'll put it right here, times the error from the previous period. Didn't change because there's nothing here. This is supposed to be an alpha 0.2. So there we are. All right. And then we just copy that down. Now what you notice is that it doesn't react very fast. I underestimate by 6, then I underestimate by 8, then by 4, then by 18, then by 13. Then I go negative a little bit and then positive again. So it reacts kind of slowly to what's happening. Now, I'll go ahead and copy this. This cell is supposed to be the exponentially smooth forecast for alpha equals 0.4. Because of the way I created it, I'm just going to cut and paste what I did in the previous and just change the alpha 0.4. It's all those forecasts for us. So now we've got here the forecast prepared for simple moving average with n equals 3, simple moving average with n equals 4, weighted moving average with n equals 3 and weights of 0.5, 0.3, and 0.2, exponentially smooth with an alpha of 0.2, and exponentially smooth forecast, excuse me, with an alpha of 0.4. The last one I wanted to do regression. So let's say hypothetically that we discover that we have a piece of data that might be informing this. So the periods are the same, the demand is the same, but now we have these special orders, and there's a suspicion that special orders influences the demand. So to test that, what we're going to do is we're going to do simple linear regression. To do that, in Excel, you go to the data analysis tab, and if you have a data analysis pack installed, it's here. Now let me tell you, data analysis is not installed by default in Excel. Why, I have no idea, but I'll show you how to do that quickly. If you go to Options, File, Options, Add-ins, and go to Excel Add-ins, you can check the add-ins you want to have available. You just check these on and then hit OK, and then it will install them automatically. So now I have it installed. So once it's installed, I go up here to Data Analysis. I can, in this pull-down menu, go down a little bit, you'll find Regression. Hit OK. It'll ask for an input range and an output range. For my input range, I want my Y's, which is what I'm predicting. That's the demand. And for the output rate, for the input range, I have X's. That's what I think is influencing demand. So I block the X's. Then I'm going to have the output appear in a new worksheet ply. And you can play around with these if you want. You can make plots and things. But in this case, I'm just going to get the numbers because I know what I'm doing with regression somewhat. So I'll hit OK. Oops, I changed it. So my Y range is the demand. My input range are the X's. Okay, and it produces this output. Now, we don't need to go through all this output because this is not a class on regression. These are measures of how well my regression equation fits. And the R squared is 0.75, which is actually pretty good. And then there's a simple analysis of variance. The key thing there is because the significance level is so small, it means that this regression really seems to be good. Down here, though, what's important are the intercept, which is the A value in the regression equation that was given in the book and the slides, and the slope, which is the B value. So 66.33 and 0.5839. Maybe I'll just copy them. Move this here, regression. So here's my intercept. Here's my slope. Intercept was my slope is this number. Now here's how these work. To find the forecasts, what you do is you take, this is going to be equal to the intercept plus the slope, and to make those absolute references, the slope times my special orders or my x value. That gives me my forecast. Now I'm going to drag all those down. There I have my forecasts. My errors are just going to be equal to the actual minus the forecast. All right, so now I've showed you how to forecast using 4 different techniques. We did 2 of them twice, so there's 6 different forecasts we've prepared. Now, if we want to assess, we'll go back to the first one now, to try to assess which one is best. So to do that, I'm going to come to this column. I'm just skipping a column because that'll make it easier because I can just cut and paste everything. We want to calculate the cumulative sum of forecast errors. So to find that, I'm going to just mirror this error column. And then right here, I'm going to add them all up. Well, I don't want to do 14, I want to do 15. And in retrospect, we're only going to add up periods 5 through 13, because that's when we're going to have errors for every forecast. For the next one, we don't have a forecast for period 4. So 5 through 14, that is 13.33, and that is my cumulative forecast error. So I'll go ahead and block those. And we'll put some color around it. So there's the cumulative forecast error. The next thing that we can look at is the mean squared error. Now for the mean squared error, what I'm going to do is I'm going to take the error and I'm going to square it. Now for the mean forecast error, what I'm going to then do is take the sum of all of those squared forecast errors divide it by the number of them. So I'm just going to count how many numbers there are there. That gives me my mean squared error. All right, now the next measure is the mean absolute deviation. So for this, what I'm going to do is I'm going to take the absolute value of the error. This basically just takes the error and makes it all positive numbers, right? Then I'm going to take the, let's see, the sum of those absolute values divided by however many of them there were. And that gives me my MAD, mean absolute deviation. So those. All right, and then we can do the mean absolute percentage error. To find this, I take the error, I take the absolute value of the error, so I'm going to take this column divided by the demand, which was here. And then what I'm going to do is I'm going to take the sum of all of those percentage errors, or the proportion errors now. I'm going to divide by count realized it's only supposed to be going from 4 down. So this should be 6 too. And I'm going to take that whole number and multiply it by 100 because it's percentages. This would be the mean absolute percentage error. I'm going to fix these two equations because I just realized I blocked too much. It should be from H6 to H6. This one I think I did right. And this one I blocked the whole thing. All right, so there we have it. That gives me the cumulative forecast error, the mean squared error, the mean absolute deviation, and the mean absolute percentage error. The final thing we wanted to have was the tracking signal. And the tracking signal is just equal to the cumulative forecast error divided by the mean absolute deviation. This is the tracking signal. All right, so what does this tell us? Well, by itself, this is just one forecast. What we want to do is we want to compare this to all the forecasts and then see which one's lower. In every case, lower is better. In the case of the cumulative forecast error being 13, what that means is we're systematically overestimating in this forecast scheme. And the tracking signal tells us the same thing because this number is positive. All right, so all I need to do now is block this, and I try to create it so that it could be, I'm going to go to cell F5 to paste. So if I go to F5 and hit paste, then I should have those numbers for these other forecasts. F5 paste, F5 paste, F5 paste, and finally F5 paste. Okay, everything is right except the last one. I'm going to undo that and go to G5, paste. Now it should be right. I'm not sure. I might have to look at that last regression. I tried to set it up so it would all work out. The rest of them, though, are right. So this tells me the different forecast accuracy measures for simple moving averages with n equals 3, simple moving average with n equals 4. If you just glance at those, it looks like 3 is better because the numbers are lower in every case. Yeah, every case. Every case except the tracking signal, interestingly enough. Yeah. The weighted moving average is pretty similar to the simple moving average with n equals 3. Here is my exponentially smooth with alpha equals 0.2. It's quite a bit worse than those simple moving average ones. And then here's the weighted moving average, or sorry, the exponentially smooth with alpha equals 0.4, which looks closer to the others, but it looks like the simple moving average with n equals 3 was the best of those. Let me go to the regression one and fix this because it's off. So the error equals E5. So the cumulative forecast error looks right. Mean squared error looks right. Oh, okay, that's what's going on. That's right. So the best one we had from the first 5 was simple moving average. So I'm going to go to click simple moving average, click on it. You can see 13, 124, 10.6, 12, and 1.2. When we go to regression, 11, 16, which is a lot better, 3.2, which is much lower, and 3.8, which is much lower. The tracking signal is quite a bit worse, but that's because the cumulative forecast error was a little lower, but the MAPE, or sorry, the MAD was quite a bit lower. So of these 6 techniques, the best technique is really the last one, regression, because this was highly correlated. But that gives you an idea of how to calculate the cumulative forecast error, mean squared error, mean absolute deviation, mean absolute percentage error in the tracking signal, how to do the forecasts in several different ways, and then how to compare them. I hope that this was useful and didn't confuse you any further.